Hi there, welcome back to the channel. Welcome to the next video in the restoration series of the Nordmende Super 250-9. Where I left off last, I just sorted out the transformer. It's been working for a couple of days, no problems. So I'm glad to say that that solution worked. Now, what I was doing before that transformer started acting up was trying to do an RF alignment for the AM. I had just finished the IF alignment and I had to stop. What I want to do now is basically carry on where I left off before the mishap. I want to do the RF alignment for the AM, and depending on how long that takes, I want to do the IF alignment for the FM. Yeah, it can get a bit boring, but it's got to be done. So I hope you stay awake and enjoy the video. To do the RF alignment, what we're trying to do is to adjust the front end so that the oscillator, the frequency that we actually get, matches what we see on the dial, and also that the front end circuits are as well aligned or well tuned to pass through those frequencies as possible. So we've got this here, and this is where it gets a little bit messy because you've got to read everything here. All the stuff is, as I've mentioned, on the actual schematic at the bottom of the schematic over here, okay? So let's take this one step at a time. The reason I say you've got to read everything is because you get to something like this, which says in the Reihenfolge KML. I think what this means is you've got to do the alignment in the order short wave, medium wave, and then long wave. This is important because some of the alignments then depend on each other. So if you do it the wrong way around, you're actually working backwards. So we'll do that. Short wave, medium wave, long wave. And indeed, they do give us that sort of order over here. So what do they tell us? They tell us that we have to align. Well, what you need to do is send a signal into the antenna, because remember, you're now aligning the front end. So you feed the signal into the antenna. It's going to be at the frequency that they stipulate, in this case 6.1 megahertz, and they tell you to align A and B. There is A, there is B, and then they tell you to move it to 11.9 megahertz and adjust C. Now these two guys are coils, and this one is a capacitor. These both adjust the oscillator so that it matches the dial pointer. And what I like to do is actually adjust the bottom end with A, adjust the top end with C, go back and forth a few times, and then adjust the peak reception to make sure that we've got the antenna circuit perfectly tuned. So that'll be the first step. That'll take care of the medium wave, of the short wave. Then we move on to medium wave, and medium wave is 600 kilohertz E and F. So 600 kilohertz E for the oscillator, it says there, oscillator, and F for the for Kreis is the front end circuit, the antenna circuit. So I'll leave that again. I'll go straight onto here, which is 1480, and you align G, which is for the oscillator. So I'll go backwards and forwards between these two, make sure that the oscillator is fine, then I'll come down to 600, adjust F for best reception, go up to, what is that, 1480, and adjust H there for best reception. Okay, then we go to long wave, same story. Long wave, I and K, 200 kilohertz is only one alignment. So I for the oscillator, make sure it's corresponding to 200 kilohertz on the dial. And then K is the antenna circuit. I think that's basically it for the UKW. And that's it for the RF alignment for the AM. Let's see if we can do that quickly. Okay, here goes. I've got 6.1 megahertz on the signal generator. Amplitude is the minimum that mine will go to. I don't know what amplitude I need, but what I'm doing is passing it through the stepped attenuator, but we'll get there in a second. So 6.1 megahertz, I've got modulation 30%, I've got an audio tone of 400 hertz. I'm just favoring 400 these days, and I'm going to send it. What I'm sending it to is to this switch attenuator where I can add 3 dB, 6 dB, 18 dB, and 24 dB of attenuation. At the moment I'm leaving it like that because I don't know how much I need. I've got the dummy antenna activated because I'm feeding this straight into the AM antenna socket. I have shortwave selected, and now I have to tune upside down to 6.1 megahertz, which is on the other side. And if you look carefully, there is actually a little, see that little marker there? There's 6 megahertz. So that little marker is 6.1. That's where I should find the signal. Let's see what happens when I switch all this on. Well, I have it on and I don't hear it, so let me see where it might be. Okay, it's just there. Put the volume down. Actually, what I'm going to do is apply 6 dB to the step attenuator. 9 dB. Yeah, that's good enough. So it's just a slight bit off, but I can improve it. There's our spot. And according to the instructions, we adjust A, which is this guy over here. Done. For now. I've set the signal generator to 11.9 megahertz, and now I've got to go up to this. If you can see that little marker there, that's 11.9. Not there. Oh, it would help if I put the volume up. Putting the signal stronger, 'cause I can't hear it. Okay, there it is. It's a little bit to the right, so I need to put it right over there. See, there it is, and the marker's over here. Now, you recall, the adjustment for the oscillator at the high end is C, which is that capacitor here, which might be stuck, so I can use a metal screwdriver just to break the seal, and then I'll use the actually, that's already there. It seems that the screw of the cap is ground, so the screwdriver did nothing to it. Put the volume up. There we go, that's done. Now at this point, as you can see, I've been doing it by ear because all I need to do is hear the signal. I don't need to worry about the signal strength or anything. What I'm going to do next is go back to 6.1 and adjust that again. Make sure that, come back a few times and make sure that that's perfectly aligned. Then I'll adjust the signal strength. I went back and forth a couple of times and now I've set it to 6.1 again. And we can keep an eye on the meter now. We need signal strength. So what I've done is I'm going to put the volume up. You can hear it. I'm going to turn the speaker to dummy load so we don't have to hear the noise. But there's our signal. It's exactly on 6.1. And now what I'm going to do is look at the peak amplitude when I adjust, what is it? B. That's the guy there. That's the antenna circuit. Oh, we got very little out of that. That's a peak there. It was practically there. Very little adjustment. Okay, so the shortwave RF alignment is done. Now we're going to do the medium wave, so we're going to put this at 600 kilohertz. Everything else is the same. I still don't know what amplitude I need to worry about, but we'll do that next. First things first, we'll select medium wave, and then we need to tune medium wave to 600, and 600 is also indicated with a little, there it is. You can actually see the 600, but there's also a little marker. So we'll put that there. Let me put the speaker back on. It's on dummy load. I don't know how strong I need it to be. Okay. Again, it's just slightly off. I need it absolutely there. And the adjustment point for that one is this one here, E. See if it's as easy as the previous one. There we go, went through the max. Now I've got the signal generator set to 1480 and I'm trying to find the 1480 on here. There's 15, there's 1480. It's not there. It's just passed, so I need to get it to there. And again, it's this capacitor. So I'm going to break the seal. I found it already and it made no difference when I took it away. So that means that that metal screwdriver is fine on this. There it is, I can hear it. Okay, so we've adjusted that. I'll go back and forth again like I did the last time and come back to do the antenna circuit alignment. Okay, I'm back to 600 and I now have to adjust the antenna circuit for 600, which according to the instructions is this guy over here. So I'll put the volume up. We'll keep an eye on the meter. I'll put the speaker on dummy. So we've got to adjust this guy. Ooh, that's a nice improvement. There's a peak, and that was quite an improvement. Brilliant. Right, up to 1480 now. We're at 1480, and I'm putting the volume up. It's perfectly aligned to 1480. I'm going to put the speaker on load. Okay, volume max. And the one we need to adjust here is actually this guy over here. This is slightly different. It's actually a capacitor to adjust the front end. It was pretty well aligned at that point, but it did move when I removed the screwdriver, so I'll do it with this guy. That seems to be a peak. Right, medium wave is done. Long wave is actually simpler. It's just 200 kilohertz. That is set. Select long wave. And where is 200 kilohertz? There's long wave. 200. Yeah, it had to be. There it is over there. There's a marker there as well. Starting, it's slightly out again. Should be there. Hear that? That's the peak. Should be over here. So let's do it. Now here they do tell you to do just one setting. It's only on 200 kilohertz, but you do the front end, which is, yeah, it's this guy over here. And then you peak the antenna circuit, which is that guy over there. So we'll look at the screen at the same time. Let's put the volume up. There's our oscillator, and now we're going to, I'm just going to up the amplitude so that we can see it on the meter a lot better. Something like that. Put the speaker on dummy load, and now we need to adjust that guy. It's a nice improvement. There's our peak. And we are done. We are done. Well, we've taken care of the AM. Let's look at what we have to do to align the FM. And in this case, I haven't done the IF alignment or the RF alignment, so both are on the table. Here we've got the IF frequency, 10.7 megahertz. That's pretty usual. And they tell us to align filters 1 and 2, or coils 1 and 2, band filter 1 and 2, which is A and B. And that's those guys over there, fair enough. And then 3 and 4, which is C and D, which is that one there and that one there. That's fine. And the ratio detector, E and F, which is again that one and that one. Now, where do you inject the signal and where do you measure? This is where it gets interesting, and I'm going to try something new. They tell us that this is the RF alignment. Let's forget about that for now. Let's look at this side over here. They say 10.7, output 50 milliwatt. Signal generated to the grid of EF85-1, which is the first tube. So it is that tube over there, the FM front end tube. Fair enough. And with FM, adjustment points A to E to the maximum. Now A to E is A, B, C, D, E. So it is A, B, C, D, E. Those you adjust to a maximum, but a maximum of what? And then point F with AM to the minimum. So point F, which is the ratio detector over there, AF means audio to the minimum. Now, this is where it gets a bit, it's not clear. Yeah, I know what they're trying to say, but it's not clear over here. What they're telling us is that we modulate AM 50% and FM 15 kilohertz deviation. So what they're telling us to do is send a 10.7 megahertz signal, the IF frequency, FM modulated to 15 kilohertz deviation of an audio tone, say 1 kilohertz, 400 hertz, whatever you want. And when you do A to E, you look for a maximum. And I think what they mean is actually an audio output maximum. So you actually are monitoring the speakers, which is not the normal way that I do this. I normally monitor the voltage across the discriminator capacitor, but I'm going to try their way. And then the last one is you set the ratio detector for maximum AM rejection, which is why they say you send an AM signal instead of FM modulation, you use AM modulation, and you adjust that one till you get the minimum output. So till you hear the least amount of tone. And that's what I'm going to do. The only difference is I'm going to inject the signal not to the grid of the EF85, but I'm going to inject it with that shield method that I've used before and that I use always on FM adjustment for light decoupling. So let me set that up and let's get started. Let's see how we set up a signal generator. This is for A to E, so we set it up at 10.7 megahertz. I'm putting in 50 millivolts RMS. This is the lightly coupling method, so I'm not sure how much I need. I'm going to use FM modulation, so type FM. Deviation 15 kilohertz, which is what they tell us to do, and we'll pass through a 1 kilohertz signal, so it's a 1 kilohertz tone, and I can activate that. And I'm again using the shield. This shield over here has got the signal coming into it. It's capacitively coupling it to the tube itself, the EF85, just like I did with the previous experiment and the way I always do it with FM to do the light decoupling. Got the speaker here, and I'm going to put it on speaker. When I want to, I can just click to dummy load. So it's on speaker. So here we go. I'll switch it on, let it warm up a bit. Now all we're doing is sending a tone frequency modulated on our carrier. So we've basically created an FM station sending a tone, okay? And it's coming through, we can hear it. Just adjusting the volume, we can hear it. There's still a bit of static, which is good. And I'm going to just flick it to dummy load. And here we go. Let's see if this makes a difference to the audio amplitude. That's what we're looking for. So it's these two over here. Yeah, it does. And that one was perfectly aligned. So let's try that guy. And that one was perfectly aligned. Okay, these two. Oh, we got some out of that one. There's a peak. That's a peak. Okay, good so far. Let's see what we can achieve with this one. Remember, this is E. This is for a maximum. Oh, nice. There's our peak. Okay. And we can hear it. Now, I'm going to put the volume down a bit, get the audio back. I'm going to change the modulation on this thing. We had frequency modulation, now I'm going to do amplitude modulation. Let's give it 1 kilohertz like before. And the depth of 50%, they say. Okay. As you can see, it's noticeably less loud, but I'm going to put sound up. Let's put the thing on dummy load, and now we've got to do this, adjust this guy here for a minimum. Look at the meter. Nope. Ah, you see that? Someone played with these guys. That is the minimum, you can hear it. That is maximum AM rejection. And we have done the, we've done our RF alignment for the FM. A lot simpler than it sounds at least, right? Pretty simple actually. And normally now I'd go ahead and do the RF alignment for the FM, but I've actually checked the channels, the stations that I know off bat over here. There's one at 88, there's one at 101.6. I'm getting them both. They're perfectly well aligned, so I'm not going to mess with that. And that means that the alignment work on this radio seems to be complete. This is what I was trying to complete before the transformer blew. But yeah, it's finally done. Good. I'm glad that that's done, because this is a very simple procedure to do. It is actually a very complex one to video and to show you. So it's actually a relief that that all went well. And so I do hope you've enjoyed it. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, please do so on Patreon. Once again, thanks for watching. Bye for now and stay safe.